Ladies and gentlemen, are you ready?
Assalamualaikum warahmatullahi wabarakatuh to Madam Zarina binti Zainuddin. In this video, my group mates and I will be sharing information and explanation about the application of standing waves in musical instrument. Next, here is my group members. As you can see, all of us are from RIS 2031B. Firstly, I'm Shazana binti Ayub, which is me. Secondly, Nasim bin Rapian, and lastly is Muhammad Daniel bin Hasim. Next, here is the contents for our video. There are 7 subtopics for application of standing wave in musical instrument video. Firstly is definition of standing wave. Secondly, characteristic of standing wave. Thirdly is how standing wave work. After that, application of standing wave in musical instrument, which is divided for 2, string instrument and wind instrument. Next, another application of standing wave. Number 6, differences between standing wave and progressive wave. And lastly is advantages and disadvantages of standing wave. Firstly, I would like to explain about standing wave definition. Standing wave is also called as stationary phase. Standing wave can occur due to combination of 2 moving waves with opposite direction. However, these 2 moving waves will have same amplitude and frequency, and this phenomenon is also called as interference. Standing wave also vibrates with maximum amplitude. Stationary phase, also called as standing wave because wave patterns are standing still. After that, I will explain about characteristic of standing wave. Standing wave can be transverse and longitudinal. In standing wave, the total energy associated with a stationary wave is twice the energy of each of incident and reflected wave. Hence, all of the particles in one particular segment vibrate in the same phase in standing wave. And all of the particles except those at nodes execute simple harmonic motion about their mean position with the same time period. Next, the amplitude of vibration of particles varies from 0 at nodes to maximum at antinodes, which is 2A. After that, all points except nodes point pass their mean position twice in one time period. And velocity of particles while crossing mean position varies from maximum at antinodes to 0 at nodes in standing wave. And the last characteristic of standing wave is if amplitude is component wave is not equal, then the resulting amplitude at nodes will be minimum but not 0. Hence, some energy will pass across nodes and wave will be partially standing, which is why it is called standing wave.
How standing wave works. A standing wave occurs when 2 waves of the same frequency and amplitude are moving in the opposite directions and interfere with each other. Standing waves are typically formed in a situation where a wave is bouncing back and forth in an environment that produces constructive interference. It has a certain point called nodes where the amplitude is always 0, and the other point called antinodes where the amplitude fluctuated with the maximum intensity. In a music instrument, a standing wave can be generated by driving the oscillating medium, such as the root of the woodwind at one end. The standing waves are then created not by 2 separated component waves, but by the original wave and its reflection of the ends of the vibrating system.
Next, we move to the important part, which is application in musical instrument. We will present 2 types of application in musical instrument, which is string instrument and wind instrument. String instrument. A guitar uses standing wave to create sound when a string is plucked on a guitar, causing them to vibrate. Standing waves are created along its length. Standing waves are created when 2 waves of the same frequency meet and cancel each other out, except for certain points along the wave. These points are called notes. The notes of a guitar string are created by the string length. The longer the string, the more notes there will be. This note causes the string to vibrate in a very specific way, and this vibration that produces the sound. Example for another instrument is violin, cellos, and double bass. The string on this instrument creates standing wave when played. By altering finger position or using different string, musician can produce different pitch and notes.
After that, I will explain about another application of standing wave. Another application of standing wave is in the functioning of microwave. For instance, a stationary wave with a certain wavelength is generated between two walls of the microwave. An easy way to see this is to take the spinning plate out of the microwave and place red licorice inside. After heating, some evenly spaced part of the licorice will appear melted or burned. This spot corresponded to the antinodes of the wave where a maximum transfer of energy occurs. So, the licorice will appear to melt or burn in the microwave. Furthermore, one easy example to understand standing wave is two people shaking at the end of jump rope. If they shake in sync, the rope can form a regular pattern of wave oscillating up and down, with stationary points along the rope where the rope is almost still, which is node, and points where the arch of the rope is maximum, which is antinodes. And another application of standing wave are acoustic, resonance, visible lights, and X-rays.
Standing wave and progressive wave are two distinct types of wave pattern with different characteristics. Here are the key difference between them. Wave motion. In standing wave, the wave pattern appears stationary or standing because the point of maximum and minimum displacement remain fixed. The wave does not propagate or travel through space, while progressive waves are characterized by the propagation of movement of the wave pattern through space. The wave transfers energy from one point to another as it travels. Next, formation. Standing waves are formed by the superposition or interference of two waves with the same frequency, amplitude, and wavelength traveling in opposite direction. The interference causes specific point called nodes and antinodes to remain stationary, while progressive waves are created by vibrating sources that continuously emit disturbance or oscillation in the medium, leading to the propagation of the wave pattern. Next, particle motion. In standing wave, particles in the medium oscillation or vibrate in a fixed position. The particles do not have a net displacement as the wave pattern alternates between regions of maximum and minimum displacement, while in progressive wave, particles in the medium oscillate back and forth in the direction of wave propagation. The particles move in rhythmic pattern as the wave passes through them. Next, energy transport. Standing waves do not transport energy through space. The energy remains localized within the oscillation medium, while progressive waves transport energy from one location to another as the wave propagates. The energy is carried by the disturbance traveling through the medium.
Lastly is advantages and disadvantages of standing wave.
The advantages and disadvantages of standing wave. The advantages is the benefit of standing wave include transmitting energy more efficiently and the fact that they can create harmonic vibration. This vibration can be beneficial in various ways, including transmitting sound and electricity production. The disadvantages is the required time required to take the number of measurements needed to establish the standing wave pattern is much longer. More modern method based on the transfer function between two microphone stations reduce the measurement time considerably. When such a wave reflects between two parallel surfaces in a row, it doubles back on itself, causing interference in the form of reinforcement and cancellation at the particular frequency associated with the wavelength.